Hello everyone, a very warm welcome to this video. In this video, we are going to talk about Flume. But before we get into Flume, let's talk about this series. In this particular section, we've been talking about Hadoop ecosystem. So the first video was introducing you to what exactly is Hadoop ecosystem. The second video was talking about how do you go about ingesting data from RDBMS to HDFS using Scoop. And this is the third video in this series, which is on Flume. Flume basically is a data ingestion tool, just like Scoop. The difference is Scoop could read data from RDBMS and dump it into HDFS, whereas Flume is an ecosystem project that will take data from log files that are continuously getting updated and dump it into HDFS. So let's take a use case for Flume. So let's say right now a game is going or a competition for singing is going on. While the competition is on, people are continuously tweeting about it. And the use case is you're supposed to show how many people are tweeting in favor of one participant or other. And this is absolutely real time. Or let's say that how many people have been visiting your site for the last 10 minutes. So what you really need is a data ingestion tool that can read data from log files that are continuously getting updated, and you want to analyze that. So let's understand how does Flume work. So anytime you want to ingest log files that are near real time, Flume is your best friend. A flume is an artificial channel or stream created which uses water to transport objects down a channel. Now, in our case, Apache Flume, it's a data ingestion tool, collects, aggregates, and directs data stream into Hadoop using the same concept. Flume works with different data sources to process and send data to a defined destination. So the way Flume works is it continuously hears out what's happening at the source. It buffers everything in a channel and finally dumps the data to a sink, which is kind of a destination. You can actually have multiple sinks. So source, channel, sink, another channel, another sink. So basically it's more like a flight which has multiple stopovers. So let's understand Flume in detail. First, let's talk about how do you go about installing Flume. Now, whether you are using Cloudera Hadoop or you are using Hortonworks Hadoop, Flume would not get installed automatically. It's not part of the core Hadoop ecosystem. So when you install Hadoop, what you get is HDFS, yarn, and MapReduce, and Flume is supposed to be installed by you. But the good news is that Flume is part of the package. Just like you install something from App Store, you can actually install and enable Flume. Okay. If you are manually installing your cluster on a Red Hat or CentOS, you would simply run yum install Flume. There are two locations where Flume will create its directories. First is userlib Flume for its primary Flume files and etc Flume conf for the Flume configuration files. Let's talk about what exactly is Flume events. Well, in the most simplistic terms, if you're traveling from San Francisco to New York via Washington, our San Francisco would be source, our destination will be New York, and Washington would be an intermediate sink, or you can say it's a channel. So quick reiteration, if you're traveling from SFO to New York, SFO becomes your source, NYC becomes your sink, and you can say in this case channel would be Washington DC. Now a passenger traveling is nothing but an event. A passenger traveling is nothing but an event. Flume sources listen for and respond to events. Events are nothing but units of data transferred over a channel from a source to a sink. A byte payload with an optional string headers that represent the unit of data. Event is nothing but a data that needs to be transported. In the most simplistic terms, let's just say that a tweet would be an event. A single log entry would be an event. So an event is nothing but a singular unit of data that can be transported by Flume. Can be individual records in a larger data set, and the Flume events can be batched and you can perform variety of operations on it. So that is an event. So you have a source, you have a sink, you have a channel, and what is transported is nothing but events. What are sources? Sources accept data from an application or server, example, a web server. Sources can be pooled or event driven. So source can continuously pool the location where data is getting generated, or it can be event driven, that when something gets generated or some event occurs, then only the data should be transported. Pooled sources are reportedly pooled by Flume source runners. Example would be a sequence generator which is continuously generating certain sequences and Flume is listening to them. Event driven sources provide the Flume sources with events. So example is netcat, where you are continuously reading what is happening on every update. Source sends events and it receives two or one or more channels. So source basically dumps or sends events to one or more channels. So we've seen what exactly is an event, and we've seen what exactly is a source. Now let's talk about what exactly are channels. A channels is an intermediate buffer for transporting events from a source to a sink. It's basically kind of a connection between a source and a sink. So let's just say that if you have source which is continuously reading, it would not really be a good idea that everything is directly dumped to HDFS. A smarter way would be to buffer it somewhere like a channel, and from there you dump it to HDFS. There are different types of durabilities and performance for channels, can be in memory or persistent. In-memory channels are fast, but they are not reliable. So if something goes wrong, you lose your data. Persistent channels will basically store the data on the disk, and even if power is lost, you won't lose your data. So what we've seen what exactly is Flume source, sink, channels. Now let's quickly talk about channel selectors. Channel selectors are basically nothing but selecting your next route. Okay, a replicating channel selector writes the same event to all configured channels. So it's like when you write an event, a replicated channel selector will write that to all the next destinations. A multiplexing channel selector will write events to a subset who are qualifying. So let's say if there is a tweet related to elections, the multiplexing channel selector will only write it to a channel which is related to elections and nothing else. You can have your own custom channel selectors also. So take an example. Channel selectors also support fanning out events. So if you really look at it here, you have a source and the channel selector is writing the data from the source to both the channels and finally ends up going to a sink. Okay, this is exactly the case for replicated channels, where data is generated in the source and that is basically returned to all the channels that are out there. And you can be selective also, that will be called as multiplexed. So what exactly is a sink? Sinks receive events from channels which are then written to HDFS or forwarded to another data source. So sink is nothing but a destination. So HDFS would be a sink, Avro would be a sink, and HBase would be a sink. So a quick reiteration. Source is where data gets generated. Sink is your final destination. Channel is an intermediate buffer. Events are what gets transferred. And channel selectors decide that once there is an incoming data, should it be returned to certain channels or every channel. You are free to have multiple syncs also. By default, it is single sync, but you can have a source and channel, and the channel would write to multiple syncs. Even that is possible. Now, while your data is basically passing through whole thing or events are being transferred, what if you want to intercept certain events and perform an operation? You can do that by writing interceptors. Interceptors allow inspection and transformation of the data as it flows through a system. It's basically capable to modify or drop events based on any criteria. So let's say I don't want tweets on a certain topic, I can actually ignore them in the interceptors. Or if I want to encrypt data, if I want to compress it, I can do all of that. Let's look at the most common design patterns when it comes to Flume. The most common design pattern is multi-agent flow, where you have a source channel and a sink and another Avro source channel and a sink. So these are like multiple routes. Then you can have fan-in. Now in fan-in, what happens is data from multiple agents is directly coming to one agent. So it's like 3 flights starting and they all end up at the same airport. Fan out would be that data from a source goes to multiple destinations and in multiple directions. So these are 3 of the most common design patterns you would find: multi-agent flow, fan in, and fan out. So let's look at how do you configure each and every individual component. Each component has its name. So you'll have each component and you can give the name. So like for a channel, you can give the max size. For HDFS sync, that's the final destination, you'll have to give HDFS path. Avro is a serialization format. So when your data is coming, you could actually serialize it in Avro. So if the data is serialized, it consumes lesser space and it's faster to process. So Avro is the choice of serialization that Hadoop uses. Simple example of netcat. So you can basically read data from a network location and dump it to Hadoop. You can also execute a certain command on the source and basically get the data. So you can run an execute command. Let's look at a simple example of a Flume configuration. In this case, we have source 1, sink 1, and channel. So on the source, we are basically running a netcat command and reading everything that's possible. Then we are buffering that in the memory with a certain capacity. And finally, we are dumping it to a sink. In our case, sink can be an HDFS also. So what we've seen so far in this video is that Flume is there to get data from log files. It has a source, it has a sink, it has intermediate buffer, and what is transported is called as events. Flume also has channel selectors, where once the data is written, should it go to multiple locations or data from multiple locations, should it go to one location? All those facilities are possible. And Flume can also let you change certain thing or process certain things using interceptors. So that is all about Flume. Thanks for watching this video.